Hello and welcome to Database Management Systems. I'm Chavita Christie, and in this video, I'm going to continue with ER models and going to explain to you how to map cardinalities, how to show different types of participations, and the concept of weak entity sets. So let's begin. So mapping cardinalities or cardinality ratios, this is where number of entities to which another entity can be associated by a relationship set. Let's take a look at some examples. So one of the cardinalities is known as a one-to-one cardinality. In this, an entity in a set A is associated with at most one entity in set B, and an entity in set B is associated with at most one entity in set A. It sort of looks something like this. You can see in A there are several entities, and in set B there are several entities. And from A, everything is linked with only one entity in B, and from B, everything is linked with only one entity in A. To show it in an ER diagram, you would have to draw it in this manner. So you will show A and B on the left and right sides of the rhombus, but on the rhombus, the lines that are going out will have arrows at the end. These arrows will show that it is a one-to-one relationship. Next, we have a one-to-many relationship. So this is where an entity A in set A is associated with any number. Any number could mean either 0 or more entities in B, but an entity in B will be associated with at most one entity in A. So it would look like this. In this diagram, you can see that each and every entity from A is associated with multiple entities in B. For example, A1 is associated with B1 and B2, and A2 is associated with B3, B4. So you can associate with as many as you like, but from this side, every entity is associated with only one entity. For example, B1 is only connected with A1, and B2 is only connected with A2. Sorry, again, A1, and B3, B4 are only connected with A2. So this way, when you show something, it is a one-to-many relationship if you look at it from A to B. And so also you have a many-to-one relationship. So this is where you will be looking from the opposite direction, from B to A. And so the definition of many-to-one is opposite of one-to-many. It says an entity in A is associated with at most one entity in B, and an entity in B can be associated with any number, 0 or more, of entities in A. And so there's a diagram for it in which several entities of A are present, and they are associated with only one entity in B. But from B, every entity is associated with several entities in A. So that's a many-to-one relationship. And to show that in a diagram, we do this. Now, notice that one-to-many and many-to-one are nothing, they are similar, just opposite of each other. So opposite in the sense it depends on where you look from. So if you take these two sets, and if you're looking from A to B, then it's a many-to-one relationship. But if you're looking from B to A, then it's a one-to-many relationship. So whichever side the one part of the relationship comes, that should have an arrow. So because it's many-to-one, on the one side, that means on the right-hand side, there's an arrow. If it's one-to-many, then this arrow that you can see after R would be on the left side. The next type of cardinality is a many-to-many cardinality, where an entity in A is associated with any number of entities in B, and an entity in B is associated with any number of entities in A. So this is where you can just connect anything with anything. There are no rules applied anywhere, and that would form your many-to-many cardinality. For this, in the diagram, we show the two lines with relation R without any arrows. That would ensure that it's a many-to-many relationship. Now, the next thing we are going to see is how to show different types of participations in an ER model. The association between entity sets is referred to as participation. And there are two types. One type is a total participation, where every entity in E participates in at least one relationship in R. And there is a partial participation, where if some of the entities in E participate in a relationship in R, then it's a partial participation. Now, look at this diagram. Here, if you look at A, then with A, there is only one thing that is not connected. A1, 2, and 3 are connected with something, but A4 is not connected. So you can say that A is having a partial participation in relationship with B. But if you look at B, then all entities of B are connected with something in A. And so you can say that B is having a total participation in this relationship. And we can take a look at another diagram here. Here you can see that both the entities are totally participating in the relationship. And that is what participation is. And I can also show it to you in a diagram. So when you have a relation between a teacher and a student, then between the teacher and student, let's say that every instructor is not teaching some student. It's possible there are some instructors who are only doing some research work, not associated with students. So that's why it would be a partial participation. So we would show it with just one single line like this. But if it's a student and every student is definitely related with some or the other instructor in the university. And so we would be creating two lines to show total participation. Now we're going to study the concept of a weak entity set. So this is the diagram here. And there are two relations here, customer and loan. And loan is the weak entity set. And you're going to know now why. And remember, it is shown with the help of a double rectangle. So when you draw a double rectangle, it is a weak entity set. And also the relationship is shown slightly differently. It is shown with a double rhombus instead of a single rhombus, which is normal. Now, let's see some of the features and understand what a weak entity set is. So an entity set that does not have sufficient attributes to form a primary key is termed as a weak entity set. And this could happen. There might be some tables with you in your database where there's no primary key available, because no matter what combination of columns you take, it does not form a unique combination. So such a table would be a weak entity set when you convert it into an ER diagram. So an entity set that has a primary key would be a strong entity set. So in this case, customer is having a primary key, so it's a strong entity set. And for a weak entity set to be meaningful, it must be associated with another entity set called the identifying or owner entity set. Now, loan is a weak entity set. It does not have its own primary key, but when you associate loan with customer, you have some meaningful relationship, because you can say that this loan belongs to this customer. And due to that, the customer entity would be identifying entity or owner entity. And every weak entity must be associated with an identifying entity. That is, the weak entity set is said to be existence dependent on the identifying entity set. the identifying entity set is also said to own the weak entity set that it identifies, and the relationship associating the weak entity set with the identifying entity set is known as an identifying relationship. So in our example, borrows is an identifying relationship. The discriminator of a weak entity set is a set of attributes that allows the distinction to be made. Now, set of attributes which are called discriminator, this is a set through which you can identify the rows uniquely. Now, how would you do that when loan does not have a primary key? So in that case, you would borrow the primary key of customer and then use that along with all the attributes of loan. And with that, you'll be able to make a primary key. For example, if you if you take customer ID from customer and keep the loan name and loan date attributes joined with customer ID, then you can get a unique combination, because it is true that the same loan name and date can be possible in the loan table, but for the same customer ID, it's not possible. So that's why if you combine, then you'll be able to make a primary key by using some other table's column. So that would be called a discriminator. The primary key of a weak entity set is formed by the primary key of the identifying entity set plus the weak entity set's discriminator. An entity set that has a primary key is a strong entity set, as I mentioned before, and the one without the primary key, which depends on the strong entity set, is a weak entity set. And so that's all for all the concepts in an ER model. Next time, we are going to see a little bit concepts of ER model that extend an ER model. They are not basic ones, they are advanced ones. So we're going to see that in the next video. So I'll see you there, and thank you for watching.